Dear learner, welcome to my YouTube channel Dr. Israel's classes, and in today's video I will discuss here about the intrinsic and extrinsic semiconductors. So semiconductor broadly can be classified into two types based on the purity or impurity. So a semiconductor can be classified into two categories: intrinsic and extrinsic semiconductor. So basically, intrinsic semiconductor are the pure state of semiconducting material, like pure germanium and pure silicon are the example of intrinsic semiconductor. On the other hand, if we talk about extrinsic semiconductor, extrinsic semiconductor are the semiconductor where we doped or we add some impurities, some trivalent or pentavalent impurities to the pure germanium or silicon. So let us first discuss about the intrinsic semiconductor here. So I'm going to discuss here first intrinsic semiconductor. So basically, as I told you, this pure germanium or silicon are the good example of intrinsic semiconductor. Uh, like here, if we have that means there is no impurity added to this intrinsic semiconductor. Let's say if we have silicon atom, the silicon has 4 electron in its outermost orbit. What happen? These 4 electrons will make covalent bond with the adjacent electron of the adjacent silicon atom. So in such a way the octet will be complete, and there will be no free electron here to carry the charge. So as you see in the figure, these 4 electrons will make covalent bond with the adjacent silicon atom, and if you see here in this picture, so there is no free electron to carry the charge or to transport the charge from one point to another point. But what happen in pure semiconductor or pure silicon? Some covalent bonds are broken due to the thermal agitation, and thus there are some free valence electron exist in pure semiconductor at room temperature. And when you applied an external electric field, the electrons will flow opposite to the electric field, and thus the conduction in the intrinsic semiconductor takes place. But this conduction is very small, and it is not applicable in electronic circuits. So we need to add some impurities, or we need to enhance, or we need to increase the conductivity of the intrinsic semiconductor. So how we can increase the conductivity of the semiconductor? We need to add some impurities. We need to add some pentavalent or trivalent impurities to the pure germanium or silicon. And when we add some impurities to the intrinsic semiconductor, then another type of the semiconductors appears here, and that name is called extrinsic semiconductor. So as I'm writing here, so extrinsic semiconductor what? Sorry, extrinsic. So extrinsic semiconductor are the type of intrinsic semiconductor where the doping is, or impurity is added to the intrinsic semiconductor. So once we add the impurity to the intrinsic semiconductor, it becomes as extrinsic semiconductors. So the doping or impurity we add to the intrinsic semiconductor may be a trivalent impurity or maybe pentavalent impurity. So based on the impurity added to the intrinsic semiconductor, these extrinsic semiconductor further divide into two categories, and N-type semiconductor and P-type semiconductor. So let us first discuss about the N-type semiconductor. N-type semiconductor are the semiconductor where we add some pentavalent impurities. That means what we will add? We add the material or substance. Those have the 5 valence electron. We add those material to the intrinsic semiconductor, and that the conductor becomes as N-type semiconductor. So what are the 5 pentavalent impurities? Like phosphorus, arsenic, antimony. These are the example of pentavalent impurities. So I will tell you that how the conduction takes place and how it becomes as N-type semiconductor, and what is the majority charge carrier in N-type semiconductor. Let us take the example here. I add 5 pentavalent impurities. I choose phosphorus. Uh, the atomic number of phosphorus is 15, and it has the electronic configuration such that 2 electron in first orbit and 8 electron in second orbit, and the rest 5 electron in the third orbit. So it has 5 electron in its outermost orbit. 1, 2, 3, 4, and here is 5. So when this pentavalent impurity is added to, let's say, a pure silicon, so what happen? Silicon has 4 electron in its outermost orbit, and here also silicon, here also silicon, and here on the top silicon. So what happened? These 4 electron of the phosphorus will make covalent bond, or will share its electron with the adjacent silicon atom, but still you see here 1 electron remains left. So thus this 1 electron is what? It is the charge carrier. So what will happen? It will transport the charge in this configuration or in this semiconductor. So because the charge carrier here is negative electron, that is why the name of this type of fashion of the semiconductor, this semiconductor after doping, is called N-type semiconductor. Alright, so now I will tell you what is P-type semiconductor here. Let's say I'm writing here P-type semiconductor. So what we did in N-type semiconductor, we add pentavalent impurity. Now in P-type semiconductor, how P-type semiconductor will make, how we can make P-type semiconductor? We will add some trivalent impurities like boron, aluminium, gallium, or indium. When we add such type of impurities, I'm going to write here boron, aluminium, and so on, gallium, that means trivalent impurity. When we add trivalent impurities to the pure or intrinsic semiconductor, let's say silicon, then this type of semiconductor is called P-type semiconductor, and the conduction or the charge carrier, majority charge carrier here are holes. So we will see here how the conduction takes place. I add boron to the silicon. Boron has 3 electron in its outermost orbit. So these three electrons will make covalent bond with silicon, with the adjacent silicon atom, right? So still you see here, this will make covalent bond here, this will make covalent bond here, and this will make covalent bond here, and here also one electron at silicon atom is left, like this. Here it will be like this, here it will be like this. So here a fresh electron will a fresh hole will appear, and this electron, let's say there is vacancy or empty space, you can say, and that empty space is called hole or positive charge. So this positive charge is left here still, so it will transport the charge here, it will conduct the electricity in this semiconductor, and since the hole is the responsible for the transporting of charge, that's why we called it p-type semiconductor. What happened when we give some external electric field, the covalent bond will break, and when the covalent bond will break, this electron will tie up with this hole, and after that a fresh hole will appear. In such a way, the conduction in this type of semiconductor will takes place. So these are the types of extrinsic semiconductors. I hope you enjoyed the video. If you enjoyed the video, please like and subscribe my channel, so that I encourage to upload new information about your subject. Thank you.